United States Army's most reliable, versatile, and effective weapon system has always been the foot soldier. He can function in many environments, handle many situations. Militarily, he can be defined as a tactical force or an offensive unit. But the Army knows that above all, he is a human being, an individual who at all times must be prepared for and protected against a wide variety of hostile elements. This is the story of how the Army mobilizes science and technology in support of every combat soldier's well-being. The story of Natick Laboratories, a field agency of the United States Army Materiel Command.
Okay, move out.
Occupying a 100-acre site not far from Boston, Natick is made up of a complex of fully equipped research and engineering facilities. The staff of more than 1,700 civilian and military personnel includes an unusual percentage of highly trained specialists, more than 200 of whom hold advanced degrees. Though they work on a variety of diverse projects within the 6 major divisions of Natick, they all share a common concern: the welfare of the United States fighting man. Nutrition is an integral part of that welfare. One of Natick's largest divisions, the Food Laboratory, is fully equipped for preparing, analyzing, and testing foods of every type. Although they do not participate in planning the Army master menu, Natick's staff of experts is frequently consulted in solving special nutritional problems. Emphasis here is primarily on research toward the design, development, and improvement of field rations for all the armed forces. Today's military strategy dictates mobility and speed. And to meet these demands, a soldier's rations must be light, small, easily prepared, and still packed with enough nutrition to keep him at top effectiveness. Currently, many kinds of Natick-designed food rations are in use, each specifically tailored for a particular environmental or military situation. There are packets for men lost at sea, stranded in the Arctic, or alone in strange territory. Each food item developed at Natick undergoes extensive testing before it is put into use. These volunteers are sampling newly developed foods under controlled conditions. Their responses are recorded for careful evaluation. Natick knows that a food can pass a battery of lab tests with flying colors, but the test that really counts comes when it is eaten. The science of food technology is still in its infancy. At Natick, each passing day hastens the transition of food preparation from a kitchen art to a skillful blend of chemical engineering. Here, a broad program of research is being conducted in food chemistry. In the division's analytical chemistry labs, scientists are trying to isolate the flavor components of certain basic foods, such as beef. Once these substances have been successfully analyzed, work will begin on the next step, synthesizing the same chemical in the laboratory. By unlocking the secrets of flavor in this way, the Army can ensure the fighting man that his rations will be at their best, no matter what the conditions. As always, the needs of men in the field dictate the direction of Natick's research. This new cola-type beverage is the lab's answer to repeated troop requests for something to mask the bitter mineral taste of water in many parts of Southeast Asia. Not bad, eh? Over the years, some of the most consistently challenging food requests have come from the U.S. Space Agency. Astronaut foods must conform to the extreme weight and size restrictions of space travel and be able to withstand severe temperatures and acceleration without breaking down. What's more, the food must not break into fragments which could float weightlessly around the cabin. Natick Research is responsible for both the original tubed foods and more recently a bar style made in bite-sized chunks. Besides development of the food, a second major area of Natick's work is devoted to its preservation. Probably the most significant development in this field since frozen foods came recently when Natick developed the revolutionary concept of freeze drying. Fresh foods are flash frozen and then subjected to drying in a vacuum chamber. Under these conditions, frozen moisture inside the peas evaporates without becoming a liquid. As a result, the peas do not shrivel up, but retain their form and appearance, even when returned to normal temperatures. They are much lighter, but still look almost fresh, and can be kept in this form almost indefinitely without refrigeration. Already, this freeze-dry concept has been incorporated in several types of Natick-developed food rations, such as the long-range patrol pack. Small and compact, it contains an entire meal which has been frozen. When a soldier is ready to eat, he simply tears it open and adds a little water from his canteen. The food quickly reabsorbs much of its moisture and miraculously tastes almost fresh. The meal can be heated or eaten cold, and when no water is available, it can even be eaten dry. The long-range patrol pack now comes with 8 different menus, each furnishing a man over 1,000 calories at a sitting, while weighing only 11 ounces. The continuous flow ice cream plant is another new piece of equipment in Vietnam. Here again, the operation is quick and simple. The ice cream mix is poured into the mix tank. The mix flows through metering pumps to the freezer where air is added and the mixture is whipped and frozen into a soft, semi-frozen ice cream. It is then put into refrigeration for hardening. The ice cream can then be packed into new lightweight insulated shipping containers for delivery to remote units in the field. The serving of ice cream to combat troops is an effective morale builder. This was in response to complaints of GIs who often found a puddle of vanilla soup for dessert at the end of their meal. Natick's General Equipment and Packaging Laboratory has the responsibility for devising packaging techniques and materials that successfully resist moisture, heat, fungi, and other destructive agents in the environment. Both small items and large are studied to determine the most effective method of packaging. Protective techniques range from sealed plastic envelopes to crushable aluminum insulation. In fact, some packaging methods in common use today were originally invented by the Natick staff in solving an Army problem. Packaging is not only designed and experimentally fabricated here, it is also subjected to a variety of hardship tests to see whether it can withstand the hazards of transportation and environment. Rotating shock drums and vibration machines make sure these lab-developed items are put to the test before they ever get to the field. Another major responsibility of this division is the design of field equipment. New and improved items for fighting men in advanced combat zones are constantly under development here. Mounted on wheels, the field laundry unit can be driven right into remote areas like a piece of standard combat equipment. This continuous bakery system developed by Natick provides fresh hot buns on short notice. Dry mix and water are simply placed in the auger and the dough is mixed and processed automatically. The machine then places the dough on baking trays which are moved back and forth through the oven several times. Finished, the buns move out on either side of the unit, ready to eat. The entire sequence takes only 22 minutes. A variety of Natick-developed field equipment can be found in nearly any Army field operation. This frame-supported shelter is a mobile maintenance facility that answers a pressing need of men in remote areas. Made of cotton over a lightweight magnesium frame, it is designed for use not only by trucks and jeeps, but helicopters as well. It's ready for use in practically any weather and any environment. This is the double-wall inflated tent. It is erected and held in place entirely by an air blower. The inflated tent is particularly useful in forward areas when frequent movement from place to place is experienced. Almost everything that the U.S. soldier carries and wears, except his weapons, is designed and thoroughly tested at Natick's Clothing and Organic Materials Laboratory. The range of responsibility here runs all the way from dress uniforms for all occasions to bulletproof armor vests. Constantly seeking to meet the challenges of new environments, the team of highly trained specialists that make up the staff usually begin work by developing just the right material for the job. A complete dyeing and finishing plant operates on Natick premises, where virtually any experimental dye or fabric can be manufactured to exact specifications. These fabrics are then subjected to specially designed tests which duplicate severe environmental conditions. They are bleached and pulled. Bombarded by intense ultraviolet radiation, which duplicates the sun's rays. This workout can compress 2 years of wear into a single week. Even the process of determining a material's color is done with precision. At the quality control department of the lab, this is accomplished with the aid of a specially designed machine called a shade spectrometer. Although these two samples of cloth appear identical in color to the naked eye, the machine developed by Natick scientists has no trouble finding an appreciable difference. It not only detects a variation, but spells out exactly what it is, with enough accuracy to satisfy even Natick specialists. Considerable work has already been done here in standardizing an optimum camouflage pattern for jungle warfare. Scientists here have learned that various fabrics register different degrees of fluorescence under infrared light and illumination now used in many night detection systems. Natick camouflage researchers are looking beyond the spectrum of visible light waves. They are now working on camouflage fabrics which will help foil this sophisticated technique, giving the soldier even greater protection in the field. It's been raining in this room for 5 days. This is Natick's rain court, one of several controlled climate chambers at the laboratories. Here, for large-scale tests of clothing and equipment, nearly any climate on Earth can be duplicated on few minutes' notice. From 70-degree sub-zero Arctic cold to blazing 165-degree desert heat. Even wind velocities of up to 40 miles an hour can be simulated, all for the purpose of pitting new products against one of the soldier's oldest enemies, the weather. Only when Natick items have successfully withstood all the environmental tests that scientists can throw at them are they ready for use in the field by the fighting man. Many of the items recently developed have been designed to help solve special problems encountered by our forces in Southeast Asia. The new combat boot is a prime example. In Vietnam, conventional boots provided little protection against jungle hazards. In response to this need, Natick lost no time in developing a new boot and seeing that it was rushed to the men in the field as quickly as possible. Designed especially for use in the tropics, this boot is considerably lighter. The nylon upper picks up very little moisture, drying quickly and permitting ventilation of the interior. It is also equipped with built-in protection against pungy stakes, a thin stainless steel plate incorporated in the sole. Another feature is the possibility of a blast-protective aluminum honeycomb wedge. The proposed redesign of a standard item is typical of Natick's investigation to meet the needs of the fighting man. As a result of the extensive use of helicopters in Southeast Asia, support of Army aviation has become an important area of Natick research. To protect chopper crews exposed to the hazards of sniper fire from the ground, Natick specialists have come up with an entire set of lightweight body armor. The air crewman's new armor consists of a cloth carrier or vest with large pockets at the front and back, where the curved armor plate panels can be inserted. This lightweight armor is not made of metal, but a fused fiberglass and ceramic, and does not restrict a man's movement in any way. So far, there has been much praise for this new equipment, which has already saved many lives. Success in meeting the air crewman's needs has led Natick to design an experimental vest of the same materials to protect infantrymen from small arms fire. Its use is primarily designed for men on patrol, standing guard, or riding in vehicles along roads where ambush may be expected. Now, for the first time, the age-old hope of providing the foot soldier with genuine bulletproof protection is becoming a reality. Another important Natick research program deals with finding ways to lighten the infantryman's load. Studies have shown that a soldier functions best if his equipment does not exceed 40 to 45 pounds in weight. Achieving this figure is the goal of the Linklo program. Some newly developed Linklo items are already in use. The new load-carrying harness was done over from top to bottom. Made of nylon and plastic, it is now considerably lighter and contoured to avoid catching in jungle undergrowth. The new materials used for the Linklo rucksack have been designed to resist fungus and chemical agents. Most important, the pack is fully 4 pounds lighter than its predecessor. A lighter entrenching tool. New sleeping gear. Every detail of the Linklow program is pursued with care and concern to please the most critical judge of all, the man at the front. But the best of equipment is of no use to a soldier until it reaches him, when and where he needs it. Development of techniques for airborne delivery of equipment and men is another important link in the chain of Natick support to the fighting man. Here at the Airdrop Engineering Lab, a staff of aeronautical engineers and parachute technologists work to provide the Army with the most up-to-date delivery systems that can be devised. Modern combat operations require airdrop equipment that can enable large numbers of troops and their supplies to be moved fast and accurately into specific locations. Recovering men from the dense jungle terrain where no aircraft can land is another problem, however. That's where this Natick item, the trooper's ladder, comes in mighty handy. Meanwhile, on Natick drawing boards is a proposed aerial retrieval system, which would permit a soldier to literally hook onto a low-flying rescue aircraft as it passed overhead at treetop level. The process of developing any new system or piece of equipment for the infantryman must always start with an investigation of the environment. What kind of conditions will he be up against? The work of Natick's Earth Sciences Laboratory enables the Army to answer that primary question. Here, cartographers, meteorologists, and climatologists pursue a never-ending study of the Earth's many environments, analyzing and tabulating every aspect of climate, soil, vegetation, or topography all over the world, which might possibly have an effect on men or equipment. This vast amount of data is obtained by searching all possible sources, from old maps and surveys to photos taken by astronauts and orbiting weather satellites. And when the data they need is not available, the Earth Science Lab goes out and gathers its own, often sending experts to the far corners of the globe. As part of this continuing effort to serve the fighting man, the lab recently initiated Project Trend in Thailand. This study calls for a detailed analysis of the Southeast Asian tropical forest environment, not only at ground level, but at points within and above the jungle canopy. A 150-foot test tower has been specifically built for this purpose in a carefully selected area of a northern Thai rainforest. Sometimes the data collected by the Earth Science staff may seem purely academic, but it pays off for the soldier in many practical and sometimes unexpected ways. Much of the information analyzed and compiled by Earth Science teams at locations around the world is rendered visually in the form of detailed maps. These are prepared by experts in the lab's cartographic section at Natick. Including such varied information as food geography zones and ranges of disease-bearing insects, these regional map series usually prove to be the most thorough ever done of an area. More important, in combination with the wealth of other data assembled by the Earth Science Lab, they are invaluable in helping the Army to know the soldier's needs and to meet them in advance. At nearly the other end of the Natick spectrum is the Pioneer Research Laboratory. Here, scientists are concerned less with studying existing data than with investigating technologies that will yield new data. On behalf of the foot soldier, the highly trained staff is exploring the future, studying biological engineering, the basic phenomena of materials, the mechanism of energy absorption, probing for new answers to old questions in anticipating the needs of the American fighting man as he enters the space age. One of the tools Natick uses in this quest is the solar furnace. Set up just outside the Pioneer Laboratory building, this instrument can be used to concentrate the rays of the sun into a powerful beam of energy. It is helping Pioneer Lab researchers and others at Natick to develop special materials and methods to protect the soldier from thermal and nuclear radiation. One such method is the thermalibrium suit. This may well be the uniform of the future. No matter what the extremes of temperature outside, the soldier within is kept cool and comfortable by a built-in air conditioning and heating system. The multiple layers of the thermalibrium skin protect him from a wide range of battlefield hazards. In effect, the soldier carries his own environment with him. The future holds many changes, and the men and women of Natick's Pioneer Labs are already preparing for them. In the Unconventional Foods Division, the study of common algae as a food source of tomorrow is under intense investigation. Containing protein and carbohydrates in surprisingly high concentration, the food value of this tiny water plant compares favorably with that of soybeans. Yet in studies underway at Natick, it has been found to grow rapidly under a variety of adverse conditions. This experiment is known as the cocktail shaker. Because, like most plants, algae takes in carbon dioxide and gives out oxygen, scientists believe it is nearly ideal as a food and air supply system for prolonged space flights of the future. In time, it may even be cultivated as an important source of food for the combat soldier on Mother Earth. As always, the accomplishments of the Pioneer Lab of all Natick's divisions can be measured by the performance of the American fighting man in the field. Whether facing the hazard of enemy fire or the hardships of a hostile climate, the combat soldier is clothed and equipped to ensure his maximum health and protection. Supported by science and technology, the United States soldier of today is ready to cope with battlefield conditions existing anywhere in the world, thanks to the efforts of the Army Materiel Command's Natick Laboratories.